Our team's product was an aluminum can, and our primary process was deep drawing, with stamping as our secondary process. Deep drawing is a sheet metal forming technique that is used to make the body of an aluminum can. Progressive stamping is also a sheet metal forming technique that is used to make the lid of an aluminum can, with the stamped metal parts generally having a much smaller depth than the deep drawn parts. In deep drawing, a sheet metal blank is placed on a die cavity and is held down by blank holders on either side of the punch. The punch then pushes down on the blank, drawing it into the die cavity, with the metal outside the cavity flowing inward. The punch typically reaches its maximum force a third of the way through the draw, with the sheet metal strain hardening as it's drawn. Any draw that is greater than the radius of the part is considered deep drawing, and the amount the part is actually drawn is its drawing ratio. Many metals and alloys can be manufactured using deep drawing, including cold-rolled steel, stainless steel, and aluminum. Deep drawing is economical at high volumes as there is very little downtime or maintenance required once the tooling and dies have been created, and while these are expensive, they typically cost less to produce than for other processes such as stamping. Typical products that are produced using deep drawing are kitchen sinks, gas tanks for the automotive industry, and, of course, aluminum cans. Some of the benefits of deep drawing are that very little metal is wasted during the process, and there's also no need for finishing as the outer wall of the part is left smooth and shiny after ironing, which is particularly beneficial for aluminum cans. Some of the geometric constraints of deep drawing are that the part can't have overhangs, must be relatively thin-walled and hollow, and the wall thickness should be relatively consistent. However, there can be up to a 25% reduction in thickness in the part wall near the base. The main variation on deep drawing is to redraw the part after it is drawn once, as shown in the image. The table shows some typical tolerances to follow when designing for deep drawing, with tolerances as small as 0.0001 inch possible through secondary machining for a cost. A number of factors relating to the actual deep drawing process also affect the accuracy of the parts produced, such as the die and punch corner radii, which can cause tearing of the blank if too low, or wrinkling of the metal if they are too high.
Stamping is a metal forming process in which a die pushes down on a sheet metal blank. This die can cut, score, bend, or punch. Stock sheet metal is fed through various stamping stations, and successive stamping operations are performed until the parts are complete. In this picture, we can see the many stamping operations that take this from sheet stock to final part. The metal is cold worked as it passes through the stations. Here we can see a typical press where one or more dies would be placed. Most metals and alloys can be used, but metals softer than aluminum are generally not listed as available on manufacturer sites. Stamping is very economical in high quantities, and it is one of the most common metal forming processes. However, the stamping presses incur a high tooling cost, so low volumes of stamped parts are not typically made. Some of the benefits of stamping include the rapid cycle times and low labor costs. Typical stamped products are car door panels and aluminum can lids. Some of the process constraints are that there is very limited 3D geometry possible. As the complexity increases, so does the tooling cost. The process also requires that the part have consistent wall thickness throughout. The typical tolerances of a stamping are plus or minus 0.003 of an inch. The main variation in the process is how many successive operations are performed.
Now that we have taken a look at deep drawing and stamping, let's see how they are applied to the aluminum can. An aluminum can uses two draws. The first draw is a shallow, wider draw than the final product. And you can see here, this operation is cutting the aluminum blank at the same time that first draw is being performed. The second draw gives the product its final diameter. This operation is doing that second draw in addition to ironing the can, which gives the can its final wall thickness as well as lengthening it. After the two draws and ironing, the dome at the bottom of the can must be created, so that is done just by pushing the product onto this dome tool. A consequence of deep drawing is ears at the top of the can. Those must be trimmed off before finishing the body of the can. The can is then necked, painted, given a lip, and that finishes the body of the aluminum can. The lid is just created in one stamping operation. You can see this stamping operation creates the lip of the lid, and it also creates the score line used to open the product when the tab is pulled. The tab is also independently stamped from the rest of the lid and in the same operation riveted onto the lid. With the lid and body created, the body must be filled and the can closed. This is done using two operations. The first operation bends the lid over the body, and the second operation makes sure that seal is airtight so that none of the carbonation escapes. It's clear that deep drawing and stamping are useful operations for creating aluminum cans because they are great for high quantities because of their low cost per unit and production. Another benefit is deep drawing actually work hardens the material and can create some strong geometries which are needed to withstand the internal pressures of an aluminum beverage can.